Hello, class. I wanted to go ahead and go over topic 5DQ1. This will also be very similar to major assignment 3, the first tab. So just so you can reference back to this when you're working on the major assignment as well. So like most of ours, let's go ahead and put our name in first and hit enter. So you're going to get some values, and what this DQ is looking at is it's looking at treatment of a well. So you have a well, it's been tested before we've done any treatment on it, and we've recorded the amount of E. coli in each of the wells. Then we did a treatment, tested for E. coli again, and found the number of E. coli. So if we want to see what happened, see the improvement, first thing we need to do is find the difference between these. So as you can see in the directions over here, it's telling you after minus before. So we're going to start with the equal since we have a calculation. After minus before. And we hit enter. Okay. So what happened in this well is that we have 3 less E. coli, number of E. coli that was found. So if you have less E. coli in the water, that's representing that it's getting safer, getting better. Okay, and that will help with our discussions as we get down towards the bottom. So you can go ahead and go through and do all of those calculations if you want, the after minus before, or we can drag our formula down. We're not going to have to lock any of these cells because we want the values to drop as we drag. We don't want anything to stay the same. So I'm just going to drag this down. And there we go. And that's going to fill in our improvement values. So notice that we have 3 different sets of values. We have the before, the after, and the improvement. Okay. So what we're going to do is we're going to find some calculations. So mean, median, standard deviation, and range. And it's basically the same thing for all 3. You just need to make sure you use the right list of numbers. So I'll just do some of these for you so you can see. Okay, so let's start with the before. So notice that we're dealing with the before. So now we're just dealing with these values and we're finding the mean. So the mean is found with equals average. The average function, we'll find the arithmetic mean. And then we'll open our parentheses. And we're dealing with the before. So I'm going to go ahead and click on the before and drag all the way down. We want the before values. Okay, and then I can go up here and just close my parentheses. Okay, so we have the average of D4 to D20. Okay, and we hit enter. And it's telling us that it's 30. And we want 2 decimal places, so we'll move that over to give us our 2 decimal places. Okay. And same thing, mean of after is going to be using the average function for the after values. The improvement mean is found using the average function of the improvement values. So same thing, the only thing that's changing is whatever values the cells that you're using. So let's find the median of the after. So equals median, and we'll open our parentheses. And again, we're dealing with after in this one, so let's go ahead and go over to our after. And then make sure we close our parentheses. And we have the median of the after values. Okay. And again, we want 2 decimal places. So we can move it 2. For our standard deviation of the improvement, we equals standard and equals an STDEV and parentheses. And then now we want to get the the improvement. So let's take our values we calculated and make sure we close. Now notice this one changed to the word improvement. That's just because that list has been named. So you can name list. Okay, we want 2 there, so let's back. Okay. And then I'll go back here for the range. Again, all of these are the same. You're just using the different list. So make sure you know where you're at. It'd probably be good to do all the before, then all the after and improvement. Okay, so the range, with the range, what you have to do is you have to calculate the max and min and find the difference of those. So let me show you how that works. So we're going to take equals max, max, open parentheses. We want the before, so let's go ahead and highlight all the before. Close the parentheses. So I have the max of our before values minus, so make sure you have your parentheses closed, minus the min, and open a parentheses. And now I need to go ahead and pick those values again and close the parentheses. So we have the max of the before minus the min of the before. Again, we'll change that to 2 decimal places. Okay. So I'll let you fill in the rest. That's just to give you a little insight on how to work through those. And then we're going to deal with finding the percentile. So this is the point where the 16th percentile would be. So you're going to have equals percentile. And then we want to work with the improvement data. So our array is going to be the improvement values. Okay. And then comma. And what percentile are we looking for in this one? Oh, my value got in the way. Let's see if we can. I think it was the 16th percentile. So let's put in for 16th, which would be 0.16, and we'll close the parentheses. And then we'll check what percentile it really was, and we can modify it afterwards. Okay. Oh, it was the 16th percentile, so we did that correctly. So 84th would be 0.84. I'll let you do that one. And we're going to get 2 decimal places again. Oh. Okay. Now for dealing with the lower bound and upper bound, this is the endpoints of in our data, in our improvement, that 68% will fall in between. So if you look at my little image over here and you envision this is all of our values, 68% of this list will fall between whatever number we calculate here for the lower bound and whatever number we calculate here for the upper bound. So we have a calculation to do to get those. And if we wanted 95% of the values, then we would have to calculate a little more. And what ends up happening is you would end up having to, for 68%, do the mean plus 1 standard deviation. 95, you do mean plus 2 standard deviations, and that would be upper bounds. But we're just interested in 68% here. So we're just going to look at our mean, which is in the middle here, our average, and we're going to add 1 standard deviation. So mean plus 1 standard deviation to get the upper bound, and then mean minus 1 standard deviation to get the lower bound. So I'll show you how to do the lower bound, and then you can do the upper bound. So equals, and again, we're dealing with our improvement data. So let's go up and Oh, I didn't calculate my mean. We're going to need that. So let's go up here and calculate this real quick. So equals average. We're going to find our improvement values. And close the parentheses. So this is going to be our mean for the improvement. And we can move that 2 decimal places. Whoop, wrong way. Okay, so we have our mean for the improvement and our standard deviation. This is what we need for 68%. We're going to take that mean value, add 1 standard deviation to get the upper, take that mean value minus 1 standard deviation to get the lower. So let's go ahead and do the lower. So that's equals our mean for the improvement minus the standard deviation. So we're taking the mean minus 1 standard deviation. That 1 times standard deviation, the 1 is not needed. If you're doing 95%, then we'd do the 2 times K11 here. Okay, so that would be our value here for our lower bound for the 68%. To calculate the upper bound, you're going to take the mean plus 1 standard deviation. And again, you're using the improvement values. And that will give you your second value, your upper value. Now, when we get down here, we're going to discuss a little bit about what's going on. What's happening with these wells? Are they showing improvement? Are they not showing improvement? So we need to look at the values we got for the lower and upper bound. Negative, that means there's less E. coli in the wells now. So that should show improvement, right? If there's less E. coli in the wells. So once you get your upper bound, you want to check to see, is that also negative? Is that showing that 68% of our wells showed decrease in E. coli? That's good, right? So that's what we're looking for in discussion. The one tricky part as these discussions is finding the number of wells. So I'm not looking for just 68% here, which it is 68%, but I want to know the actual number of wells that 68% represents. So let's talk a little bit about how to calculate this number. I'm not going to use the exact 68%, and I'm not going to use the number of wells that we have in our experiment here. Those are the calculation I want to see you figure out. So let's say we are trying to find 95% of the wells, and maybe there were 85 wells. Okay, so 100% would be 85 wells. We want to know 95%. How many wells represents a 95%? So we're going to go equals our 95% times the number of wells. So if you're ever trying to find a percent of something, you take the percentage times the number, the total number. So we end up calculating here that 80.75 wells would represent 95% if there were only 85 wells. Okay, so you're going to need to work with calculating with 68%, and you need to figure out how many wells there are. You have a list here that's numbered, so just go to the bottom. And that should get you to the actual number of wells. You'll have your lower and upper bound already calculated, so you just need to drop those into your discussion and then discuss a little more here on sort of on your own, being creative on what happened. Okay. All right, I hope that was helpful in getting you going or getting you started on the DQ. Have a good day.